I'm going to put on recording and start sharing. And yesterday we started discussing about generics, is it? Generics, and we discussed generic class and method, is it? Okay, so that's the just the concept. It's quite straightforward, is it? We will learn more, okay, today. And so it's regarding generic type. Generic type, is it? And identified by the angle brackets, is it? And within it, we can plug in with some type parameter. But it's not just limited like as T, is it? You can also do like T extends, is it something else, is it? So that's called bounded generic type. Is it? So that's what we learned yesterday. And we also discussed, is it generic type, the benefit to compare with raw type. Raw type is from some legacy code. Okay, it's JDK 5.0, is it? And I use this for ours as JDK 8 above, okay? Right now it's already JDK 11 or 12, okay, something. So it's the legacy and the raw type, you remember, compare with the raw type is generic type helps to catch error in compilation time, is it? In compilation, is it? Versus the runtime error. And also it's very flexible once you have generic, is it? You can just define one single class, one single method, but you can apply it to different various type, okay? Okay, so here is a question, okay? So this is going to be our first quiz question. So when we said the generic type, is it the type parameter that T or T extends something, whatever, is it? So that T, when you plug in, when we plug in, can we plug in primitive type? Can we plug in with primitive type? Or we see when we plug in, we call it what? We call it a type argument. So the question is do we allow type argument to be primitive type? So true or false? That T. So for generic, the type, can a type parameter be a primitive type? Any recommendation? Remember, we cannot, okay? So primitive is going to be false, okay? So you can send your answer to the chat. So this is a quiz. You cannot, okay? This must be what? Must be reference type. So you can keep notes that, okay, it's a reference type, okay? Reference type, so it can be class, some class. It also allow interface, you remember. It also allow array because array is also reference type. Is that okay? So keep this in mind. Okay, don't you cannot plug in integer, number, the int or char. Okay. Okay, so today we will learn another new concept, but before we move to that, so let's take a look. So this is our example. It's called generic. In our class notes, you will find the complete example. It's called Java generic bounded wildcard, example 3. Okay, and over here, if you take a closer look, I have a package called animal, and I have another package called the Java generic bounded wildcard example 3. Okay, so in the example package, I have 3 Java files. So basically, I define a class called animal and 2 other class called pet and wildlife. Okay. So for this animal class, it's pretty straightforward. It has a bunch of instance variable, and this count is a class variable. It's pretty straightforward. Okay, then constructor, then of the get method, and the corresponding set method, and some method. And we also have a clone and 2 string, and we also override objects to the equal method. Okay, so nothing new here. And then the pet method, it's a okay. So let me ask you as a. So this is going to be the second quiz question. So what is the relationship between pet and animal? These 2 classes. So the relationship between pet class and the animal class. What's the relationship? In OOP concept, is it we learn some keyword regarding OOP. So
Pet is a subclass of animal.
yeah, very good. Pet is a subclass of animal, is it? So this is the inheritance relationship, is it? Yeah, so that's the answer. You can send your answer to the chat, okay? So over here, pet is a subclass of animal, so it can inherit some of its non-private instance variable, is it, and method, okay? So anyway, it has get, set, its own as equals, is it? And the wildlife similar, is it? It's also a subclass of the animal, okay? So nothing new here. We all know this class pretty well, is it? And next, let's see this one. Okay, so over here, we import the package, is it? Animal, and we also we import the animal class, pet class, and wildlife class. Okay, we import them in order to use it. And over here, let's take a look. Okay, why I cannot use? Okay, so I have an array list 1, and the type for this array list is the animal class that we just created. Is it? Then I create a new animal called eagle. Is it? And I add eagle to my array. Is it? And then I add a wildlife also to this array. Is it? This is allowed. Is it? Because wildlife is a subclass of animal class. So it is also an animal. So you can also add a wildlife to the animal array list. That's fine, is it? And then next, let's take a look. The add animals method here we have. We have a method called add animals. it pass in an array list of animal, and it add a wildlife. Okay, so let's take a look. That method called add animal. Okay, this add animal method it's a class method, and the first parameter is an array list. Okay, array list, and the name is called list. The second parameter is just a wildlife. Okay, nothing new. But here, the angle brackets, you see this time it's not a T. We use a question mark. Okay, so this is not called generic. This is called wild cards. Okay, it has a lot of similarity between this and generic, but it's not generic. This is called wild cards. Okay, wild card. And over here it says super wildlife. So this question mark can be what? It can be any of wildlife objects, or it's super type. So it allows wildlife and animal. So whoever it's super class, that's what this super mean. Okay, so this kind of wild cards, we call it lower bounded. Be careful, okay, lower bounded wild cards. Okay, and then, okay, this array list just call that add method. Okay, so you can use question mark also, but it's called wild cards. Okay, and generally speaking, wild cards only used for method, okay, as parameters. Okay, generally we don't use it to create a generic class. Okay, they use a lot to define some method. Okay, so this is that add animal. Is it method? So this is what? This array list. This array list, the type is what? It's array list animal. Is it the parameter it allowed is question mark, super wildlife. Is it wildlife? And animal is wildlife if we draw the relationship. Is a parent class of wildlife. So this is a lower bounded wild cards. Is it? And animal is super. So this is working. Okay, this is legal. Is it? And the second parameter, the type match. Is it? Because whenever you call method, okay, you call method, and Java is a type, strongly typed language. Programming language. Is it? And some programming language is not typed language. Okay. Anyway, so it's a strongly typed language. So your method is that when you call method, so method parameter type should match. You plug in, we call it argument. Those two types should match with each other. Is it? So the wildlife, anyway, it matches. Is it? The first one, it matches. Is it because it's lower bounded wild cards? So you see, this then allows a lot of flexibility. Is it? Okay, then let's keep saying, okay. And then I create another wildlife, is it? And I call that method again, is it? Method again. And then next, let's see over here. we call another method called print list. Is it print list? So what is print list method looks like? Let's see, the print list method, yeah. Over here, this is the print list method. This method, the parameter type is what? It's just a wildcard. Is it? And this kind, if you just have a question mark, it's called unbounded wildcards. It's unbounded. Okay, it's unbounded. So it allows any type. Okay, and this is an array list. Is it array list? So you can use for each loop. Is it? This is for each loop. For each loop. But the question is, Java is a strongly typed programming language. Is it? So whenever you name a variable, this is different from some of the other programming languages. It's not typed. Is it? Then you need to give the variable a type. So this loop variable is, and what type should I give? Because over here it's a wildcard, is it? Okay, you just use object. Okay, that will work. Why? Because object is root class in Java, is it, of all other classes. Other classes, is it, in Java? So this will work, is it? And the exact type E will be dynamically binded during runtime. Is it? That's what we learned before. Is it OOP? Is it dynamic binding? Is it? Okay, anyway, so you use this unbounded type. Is it? That will allow any type. Is it? And if you take a look at my commented out part, if you write the function like this version, print list, you say, well, then why don't I just use the object? Is it? I say, all of the other class, a subclass of object, why don't you just use object for everything? Why do we need wildcards or generic type? The question is, if you use object, then the array list, the argument type must be array list must be an object. So the array list type must be object array list. Okay, not any type. So then in this case, our array list is an animal and array list, so then that won't work. Then you need to do some other manipulation. Okay, so that's not flexible. Okay, so be careful here. Okay, you can try after you go home. Okay, so anyway, so this works. We proved it. Is it? And next, let's see. The second array list is what? It's a pet array list. Then I add pet. I keep adding pet. Is it? And then I call a remove animal function. Is it? So let's see what the remove method works. So here is that remove one. Okay, this is remove method. The second parameter is pet. The first parameter this time is still that question mark, but it says extends animal. So this is a little like what we learned yesterday. Is it bounded generic type? But this is upper bounded wildcards. Is it? So it will allow us. So the question mark can be animal and its subtype. So it can be pet. It can be wildlife. Is it? So you are going to call then the array list remove method. is it? So this is called upper bounded wildcards, okay? So be careful. Okay, so it's upper bounded, is it? So this array list is packed, is it? And of course it's working because pet is a subtype of animal. So this will also work, is it? And then this time, if you take a look at the print list also works, is it? We have that a single print list. This array list type is what? Is animal. And this array list type is what? Is pet. Is it? Both work. That's because in the print list method, is it? It uses unbounded wildcards. Is it? So that's why it works for all of the cases for this print list. Okay. So then you can see it's quite flexible. Okay. So that is this method. We are done. Okay. Then next, let's take a look. The last, I think, yeah, I believe this is the last example regarding generics. Okay. The last example on our class website, the notes, you can find it. It's called Java Generic Stack. Okay. So let's take a look. Oh. Okay, so this is stack class. You remember previously we implemented our own version of stack using array, is it, if you recall, is it? And that stack is an integer stack, is it? So that's not flexible. And in Java collection, that stack we use is a generic stack, is it? So can we also define our own generic stack? Yeah, here we show how to do it, is it? So we rewrite our stack class as a generic one, is it? So this is generic. And it implements clonable and comparable and the iterable. And this iterable, did you see this time? It's also a generic. And previous we discussed the stack is implemented using array, is it? Okay, so then over here, the array instance variable type now change it to T, okay, generic type. Okay, then in our default constructor, because this is a reference type, is it? So it needs allocation of heap memory. Is it? So how do we do that then for this array? Because it's a generic type, so how do I do that? Yeah, you cannot do new T. That is not allowed. Okay, whenever you call new, following it must be some concrete type. Is it? So over here, then how do I do that? I call new, you call object. You can do that. Okay, and with a specified capacity. And then what? You cast it to the generic type. Okay, so here I cast it. And be careful, here is the array. So if you want to cast the array, then you need to do T empty square brackets. Okay, so keep this in mind. Okay, and we also initialize the top index to -1, nothing new here. Okay, and for the explicit value constructor, then the same thing, is it? But it's just when you allocate memory for the array, you use the specify parameter, the capacity. Okay, so that is the two constructor. Okay, the empty method pretty similar as what we did before. Okay, and over here for our push method, we didn't do the stack full exception. Okay, over here we double the size. So when stack is full, we double the size, double its size. That's what we did here. So how do we do that? Okay, so you check if stack is full. If stack is full, we create a temporary array. Is it called new object? And you double the array size. Is it? And then we do deep copy. Okay, this is arrays deep copy. You can also call system.array copy. Okay, and you do from source to destination. Is it to specify the starting index and how many elements you want to copy? Is it? And then you can add the new item to this. Then you can reassign it. Is it? Let this variable point to the new memory location. Is it reference? So then how about the old one? The old one is garbage collection. Is it? Okay, then you can assign it to this new location. Okay, new item. Okay, element. And for pop, it's similar. Okay, so you still need to take care of the empty exception. Okay, and the pick is just to retrieve the top item. Is it? So nothing new here. And the toString method is pretty similar. Is it as what we discussed before? And here also the clone method. Okay, be careful, this clone method we override from who objects. Okay, and because over here we implement the clonable interface. Is it? So that's why you need to take care of this exception. Clone not supported exception. Okay, you must throw this exception. Okay, the clone method, this clonable interface is a marker interface. This clone method is from object class. It's not from that clonable interface. Okay, so be careful. Okay, how do I do that? Okay, I create a new array. Is it to create a new stack? And then I do deep copy. Is it? So here is another way you do array deep copy. Okay, array deep copy. Okay, that is this method. Not a lot of new things. And then for the comparable interface, is it? You need to implement the compare to method, is it? And here you compare what? Compare with another stack. Be careful, okay, another stack. Okay, and what over here is we use the size. We use two stacks size to determine, okay, who is greater than the other. Okay, it's very, very raw. Okay, and anyway, so not a lot of hard thing to understand. And then the last one is regarding our iterable, is it, interface. And this time our iterable interface is the generic one, is it? So that's why its iterator is a generic iterator, is it? So that's, I don't know why this, okay. So that iterable interface, you need to override its iterator method. What it does, it returns some iterator. is it? So that's why over here, we define an inner class. This is an inner class. And this inner class implements the iterator interface. Is it? And the iterator interface has what? There are three methods you need to override. Is it has next, and remove? Is it? Okay, so this is pretty similar as our Q1, if you recall. Is it? Okay, so this inner class, it implements that iterator interface. Its instance variable for this iterator is we use the index. Okay, and we initialize the index as a top index. Is it? And so over here we do top down. Top down when we do iteration with stack. Okay. We do top down. So has next, if you haven't reached the bottom, is it? You always has next item. Is it? So that's why we use this index greater or equal than 0 to check. Is it? And how do I get the next item? Is it? So the next item is if it still has next, is it? You just get its index, get the specific array element. Then you decrement the index. Is it? Then you return that item. Is it? For remove, we didn't implement here. Okay. So anyway, this is the stack. Then let's take a look. Okay, so this time we have our own generic stack. Is it? And then for this stack, then I want it to be an integer stack. Okay, then you can call it push method. Is it? And over here, we have two different search items. We want to search some item in our stack. Is it? So let's see, how do we write those two search methods? Okay, the first search method. This is the first search method. This search method is search some number. This is some number. And the first parameter is that stack. Is it? But over here, it means what? We use a wildcards. Is it? The wildcards, it allows number and its subtype. Is it? So it can be number, can be integer. Is it? Can also be float. Is it double? Is it those numbers? Is it? So they will all be allowed. Is it? Okay, then how do, because over here, I first try to use to call the stacks clone method to create a clone so that when I do pop, I won't change my original stack, this stack. Okay, so I create a stack object called stack clone. And if you take a look, this stack clone, it's also a wildcard. Is it? So it says wildcard type can also be used for parameterized, okay, to declare a variable. Okay, that's also fine. And then you can call the clone method. Is it? Clone method returns what? It returns the object. Is it? So that's why here you need to cast it. Is it? Cast it so that it matches the variable type, okay, because Java is strongly typed language, okay. And then you can loop through, you can do pop, is it, and do the check, is it equals, okay. So nothing new. And because the clone method, has the clone not supported exception to thrown. Is it? So that's why here you need to use that to try catch block, okay, to take care of that. Okay, so this is the first search method. And the second search method, the search to method. Is it? So it's the parameter type, it's similar. Is it? And over here I use for each loop. Is it? And so here is the question, the third quiz question. Why I can use for each loop here? Why I can use for each loop? This is for each loop. Why I can use this for each loop? Who remembers? Like my animal class, can I use for each loop for my animal class?
Does number implement iterable interface?
Yeah, it's because what? Because, okay, let's go back. Oh, I needed to first clear everything out. Let's go back to the stack class. The stack class that we defined implement what? Implement the iterable, okay? If you cross this out, you cannot do for each loop, okay? It's because you implement. So the answer is because the stack class implements iterable interface. Is it? It implements iterable interface. You remember? It returns using iterator. Is it? That iterator will let your index starting at where? Starting at the top of your stack. Is it? And internally, even though you didn't see, but internally it will call has next, next, has next, next within a loop. Okay, that's why you can do for each loop here, okay? Be very careful. So that's our third quiz question. Not all class you can do for each loop, okay? It's because this stack, it is what? It's a stack. Is it? The stack implements the iterable interface. Is it? And that iterable interface has a method called iterator. This iterator will let loop start at a specified position. This position is some index position. Is it? Then because it has a method has next and the next. Is it? This next will advance the loop index. Is it? Okay, so that's why it can work. Okay, keep this in mind, okay? Okay, and then let's see the next method. We don't need to worry. Okay, so we have those search and search to. Is it search and search to? So anyway, here it just shows the stack type is integer. Is it? But the search method, the parameter type is what? Is wildcards extends number. Is it? So it's what? It's lower bounded type. Is it? Not type. Here we call wildcards. Is it? So that's why it allows its subtype. Subtype are what? In this case, integer is its subtype. Is it? So that's why it works here, okay? Be careful. And then next, we have a double stack. Is it? Then we add some number. Then you can see, here we call this search and search 2. Is it? This time we pass in double stack. It's also allowed. Why? It's because it's subtype of number. Is it? Yeah, that's why it is allowed. Okay. And then next we have an integer stack. Is it? We fill the stack. And we can compare the two stack. Is it? Because we implement a comparable interface. Is it? So here you compare two stack. Is it? So nothing new here. Okay. And then what next is just some clean sentence method. And then let's see what the clean sentence method do. The clean sentence method, this is pretty straight. Just take off in a string if a character is not a letter or a digit, then you just remove it. So in Java, if you want to check a character, if it is a letter or it's a digit, you can call. So this is from character class, is it? So then the question is, this two method, it's character class is instance method. So choice A, choice B, class method is letter and is digit. So multiple, so this is our next quiz question. This is the fourth quiz question. Is digits and is letter. So character is a class. Is it? It's a class here. And within class, you can have method. Is it? So is digit and is letter, it's instance method or class method?
It's a class method.
Yeah, very good. It's a class method. Okay, B. Okay, it's class method. Okay, and then you can also convert, is it a letter to lowercase or uppercase? Okay, here we use a string builder. Okay, but not to use a string. And you should remember the benefit of string builder. And the next, the reverse string. So here we use a stack. You remember when we discussed stack is LIFO. So it can be used in a lot of application with reversing, is it? So here we create a stack called a char stack. It's a character type, is it? And what we are going to do is we get each letter, is it, from the string, is it, and we push it to the stack. Is it? And then we get each letter out of the stack and append it to a string builder, reverse string. Then we can reverse the string. Is it? Okay, so nothing new here for this reverse one. And then this example's last part is we first, so this is a sentence. We first clean the sentence. Is it? So we take off the space. Is it? And the question mark. We just leave off the letters. And we also convert it to lowercase. Is it? Lowercase. And this is a clean sentence. And with the clean sentence, then you reverse it. Is it? Using stack. So use stack to reverse. Is it to reverse? And then you call strings equals method to check if both strings are the same. If both strings are the same, then you say, okay, this is Pollinger. Is it in stack unit? We learned how to check Pollinger. Is it okay? So basically, that's